Angles in circles. Okay, so today we're going to talk about all of the angles that you need to know. So we started with central angles. Okay, so 70 degrees equals 70 degrees. Got it, easy peasy. Then yesterday we talked about inscribed angles, where this arc is 70, this intersected arc, and this inscribed angle is half the size. So inscribed angles. But then there's other angles. So there's two other ones we got to deal with. We got to sort of figure them out. So if I just take two random chords, and that's not the center of the circle, it's just a random intersection, and I want to figure out how big this is, that angle, we're going to call that an interior angle. Okay? And if we have an angle that's made with two secants, or a secant and a tangent, or two tangents, this angle way out here, we're going to call it an exterior angle, just so we can talk about it. Okay? So there we go. So we have central angles, which are easy, inscribed angles, which we've seen before, and then we've got these two random ones. These are the new ones we're going to talk about today. Let's start with random interior angles created by chords. So what we're going to do, or what the idea is we're going to talk about the arcs in relationship to the angles. Okay? Now, what do we know about these two angles that I marked down? Those are vertical angles. So really, they're equal to each other. So let's just focus on one of these angles because they're the same. So let's say this is X. Well, if it was a central angle and this was 70 degrees, that would be 70 degrees. And if it was an inscribed angle, it would be 35 degrees. Well, that's not going to work in this case. We need to deal with what do we do when this is, let's say, 90 over here. Okay? So you've got these two arcs that are not the same, and you've got a random angle that we got to figure out. Sounds impossible. Let me give you a hint. If we had central angles, and this was 50 degrees, this would be 50, and this would be 50. What is 50 plus 50 divided by 2? That would be 100 divided by 2, or 50 degrees. So that's a weird thing to do. It seems like we just wasted our time, but let's try it over here. My hypothesis, and it's not really much of a hypothesis, is that if we average these two intercepted arcs, we will get the angle that is attached to those. So this angle is actually 80 degrees. So if we average the two arcs, adding them together, dividing by 2, you'll get 80 degrees. So that's an example. So that's interior angles. Now this trick actually does work for central angles, as you just saw. It also works for inscribed. So imagine this. So you've got an angle here that's 80, and I say this is 40 degrees, right? Well, what's the other arc on this side? Isn't it like 0 because there is no other arc over there? So what's 80 plus 0 divided by 2? Isn't that 40 degrees? Yeah, it is. So this system works for any angle inside or on the circle. It works for all of those. So let's consider this the positive space. This is the positive space inside the circle or on the circle. And the reason why is we are going to consider an angle that is outside of the positive space. Outside of the positive space to be an exterior angle. Okay, oh, what am I doing here? All right. I'm going to rip this apart, but let's see. Okay, all right, there it is. So look at this. You got two secants, and this angle's outside. So we're going to call this the negative space. The reason why I want to call it the negative space, I'm making this up, by the way, is because we are not going to add these two arcs together. In fact, we're going to do the opposite. So this makes absolutely no sense. It is a formula, and the formula goes something like this. If this is 90 degrees, and this is 40 degrees. To find this angle, it's 90 minus 40 divided by 2. Notice, it's subtraction when it's outside. The reason why it's subtraction is if I move this on the circle, the angle actually gets bigger. If I move it farther away, I know it's hard to tell, the angle actually gets smaller and smaller and smaller. Let me hold this down. Smaller and smaller and smaller the farther you get. The closer you get to these 2 points, the bigger the angle gets. So smaller, smaller, and in fact, it gets way out there. So your answer is going to be an average of these two things. So it is 50 divided by 2, which is 25. And I'm going to go out on a limb and say the odds are, when you're done with this, this number probably should be smaller than both of these, because we're subtracting and we're dividing by 2. So for outside or exterior or the negative space around the circle outside, we're going to subtract and divide by 2. So we're not averaging, we're subtracting and dividing by 2. And this works. It's genius is really what's going on here. So let's check it out as all together as like a formula sheet. So here we are, back at these 4 shapes that I wrote earlier. The formula, if you want to call it a formula, is the angle x equals the arc. Okay, that's the formula. The angle equals the arc. I guess I could have put angle there, right? The inscribed angle is the angle equals the arc divided by 2. That's the formula for this. So this could be using for algebra. I really don't like this. So angle, all right? So now you've got this. This formula is the angle equals arc plus the other arc, 1, 2, divided by 2. And the last one, the angle, is the arc, the bigger one, minus the smaller one, 1 and 2, divided by 2. Those are the formulas. Now there's variations to this. We could use tangents on a couple of these. It can get a little crazy, but that's the main idea. Okay, here's my first example. We have an angle we need to figure out. This angle is on the outside or the negative space. So even though we have a central angle here, this is supposed to be the center, we're still dealing with this angle. There's probably going to be some relationship here. So if you remember, for an exterior angle that's outside the circle, the angle equals the arc minus the arc divided by 2. So we've got this arc here. What is this arc? That's right, it's 90 degrees. So 90 minus 35 divided by 2 is going to give us our angle. That's your setup. Now, they might give you the number. They might say this is x. Or they might give you these numbers and say this is x. No matter what's going to go on, you're still going to sort of set this up and put the x where necessary. So this one's an easier one. So 90 minus 35, let me use my fingers really quick. 1, 2, 3, 55 over 2, I think. Yeah, I think that's right. And then 55 divided by 2, that's 27.5 degrees. Okay? I gave you some arc measurements. I want to know how big that angle is. So looking at this, we need to talk about the intercepted arcs to the x. That's 30 and this arc over here. Is there a way for you to figure out how big this arc is? That's right. It's 360 minus 40 minus 30 minus 60, whatever that is. So let me just do some quick calculations. 230. That is the angle measurement for that arc. So now we have an angle here. Is it a central angle? No. Is it an inscribed angle? No. Is this angle on the inside or the outside? Inside. So what we're going to do, this is the positive space. We're going to add the 2 arcs and divide by 2. So that's 260 divided by 2. That angle is 130 degrees. That's the answer. Let's try another one. Even though they're tangents, it still works the same as our earlier formula. Let me grab that formula really quick. Remember this? That's an exterior angle right there. We use the subtraction. That's an exterior angle. We're going to still subtract, the two intercepted arcs. We've got a 300 here. Uh-oh. 360 minus 300. This is 60 degrees. Now, it doesn't really look 60, but let's just go with it. So here we go. We got these two arcs, 360. If you add them, you're going to get the wrong answer. We need to subtract these and divide by 2. Why did we subtract? Because I made up that whole idea of a negative space, a negative minus space out here. That's the positive space inside the circle. So if you do that, you have 240 over 2. The answer is 120. Now, let me make a note. There is a special thing you could figure out on this problem. Some people memorize this. This is optional. They figure out that if you have this exact picture with two tangents, these two numbers are supplementary to each other. $60 plus 120. This is 120, remember? Don't those add up to 180? It always works that way. It's sort of freaky, okay? So that is the last basic one. Here's this weird problem. I made it sort of crazy. So it's not horrible. There's no quadratic. There's no x squared in here. But it does require some skill. First thing I would do every single time is identify the type of angle. So what is it? Your four choices are central, inscribed, interior angle, exterior angle. There's the center of the circle. It's not a central angle. This vertex here is not on the circle. It's not an inscribed, and it's inside the circle. So because of that, this is an interior angle. The formula is arc plus arc divided by 2. So second, know the formula. Okay? You need to know the formula. Now, do you have to write it down? Probably not, but you do need to know the formula for this situation, or else you're going to get the whole thing wrong. The reason why I say you need to know the formula is this is algebra. There's a 2x here. There's an x plus 10 here. There's 120 degrees here. This is a little more complicated than the last examples I've showed you. So the angle, do we know what the angle is? No. You're going to put 2x. So third, set up. 2x is the angle. One of the arcs is x plus 10. The other arc, I don't know what the other arc is. Is there a way? Is there a way in this picture to figure out what the other arc is? Is there some kind of useful information? I know 360, but we don't know either one of these right now. 360 is not going to work for us. This is the diameter, okay? This diameter means that this is half of the circle. This half adds up to 180. So if this adds up to 180, this has got to be 60 degrees, okay? So if this is 60, this goes here, divided by 2. There's your setup. So this is 4x equals x plus 70. I'm simplifying my algebra problem. I subtract this, I get 3x equals 70. X is whatever 70 divided by 3 is, some gross number. But that's the answer. Okay? That's the answer. Now you might be like, well, wait a second. Can't I just say that those add up to 180? No, you cannot. Is this line a diameter? It's not a diameter. Because it's not a diameter, you cannot say these add up to 180. So that's not going to work. The only two angles you can say that add up are 60 and 120. This is a very complex problem just because I got weird stuff going on. And the answer comes out gross. So when you finish, that's our last step, by the way. When you finish this, you're going to get this gross angle and you're going to be like, oh, I must have done it wrong. Maybe you didn't. I would just double check your formula. Double check that you added since it's interior. And hopefully you did your algebra steps right. If you did it twice and you get the same answer and you think you did everything right, you're going to have to go with it.